Hello and welcome to the Physics 121 pre-lecture video on one-dimensional kinematics, definitions, and basic concepts. Hi, my name is Corbin Covalt. I'm the instructor for Physics 121 of the Calculus-Based Introductory Mechanics course at Case Western Reserve University. Welcome to the class. This is the first of a series of pre-lecture videos that I'll ask all of our students to look at before they come to lecture. Note that this is one of 3 video clips that I'm going to ask you to look at before the start of lecture on Wednesday. That would be Wednesday, August 26th. So please plan to watch all 3 of the videos and answer the questions on the Blackboard site below before class starts at 11:30 on Wednesday, August 25th. The first video is going to be on the topic of kinematics. We're going to be talking about one-dimensional kinematics, the basic concepts, definitions, position, velocity, and acceleration. Okay, here we go. So we're going to talk about one-dimensional kinematics, the description of the motion, definitions. So in one dimension, if I'm interested in describing motion, I start with the concept of position, where a body is located. And if I'm talking about one-dimensional motion, I'm talking about motion constrained to a line. So here I have a number line, numbers going in the positive and negative direction. And I can talk about a coordinate on that line x, corresponding to the position. So if I have a body, like that particle there, a little red particle, that particle is located at some position at some time, and it could be moving. So I have x as a function of t, position as a function of time. So for example, let's talk about the motion, the kinematics of a monstrous badger moving along a narrow hallway. A monstrous badger. There he is. And we're going to have a bird's eye view of him as he moves down this hallway. He can move forward or backwards in a straight line down the hallway. So to indicate his position, we'll draw a number line, a coordinate system, x, where we mark a 0 position and a positive going this way, negative going that way. So we're going to start at a time t equals 0, corresponding to a position x equals 0. Here goes the badger. So he starts just sitting still for a little while, then the badger moves forward in the positive direction a little while. He gets to a certain point, backs up, then goes forward again and accelerates away. Okay, let's make a plot of the position of the badger as a function of time. So we're going to make a plot. We're going to plot position versus time t. So that's x versus t. And the badger is starting at the origin, which is to say the badger starts at time t equals 0 at position x equals 0. So the badger starts by not moving for a little while and then moves forward, so his position increases until he begins to move backwards and his position decreases, and then he goes forward again and accelerates up and his position increases. Just like that. So this description is a complete description of his motion. This is the kinematic plot, sometimes known as a world line. Once I have x versus t, I know everything about the motion of the badger. So now we will talk about the definitions of velocity and acceleration. So we're going to define the concept of velocity as the time derivative dx dt. It's a derivative, so graphically it's represented by the slope of the position versus time. So some instant on time I can define a tangent line, and the slope of that tangent line is velocity dx dt. Here it's positive, corresponding to positive velocity. Here it's negative, corresponding to negative velocity. And here the slope is flat, corresponding to 0 velocity. Likewise, we can define the acceleration as the time derivative of the velocity, which is just the second derivative of the position. So, since it's the second derivative, corresponds to the curvature of the position versus time plot. So if the curvature is negative here, the velocity is less than 0, and the curvature being positive upward here corresponds to an acceleration positive in the positive direction. So these definitions of velocity and acceleration are always true. You can always take the time derivative to get the velocity, of the position to get the velocity. You can always take the time derivative of the velocity to get the acceleration. It doesn't matter how complicated the motion. The velocity is defined as the time derivative of the position, and the acceleration is defined as the time derivative of the velocity. Thank you. And kittens. And kittens. Kittens. And kittens.